Alright, so the lesson is 5-5. The actual problems are in 253. It's 1 through 11. Now the real lesson says solving multi-step equations and inequalities. This is an inequality. We're not doing that today. We're not going to do any of the inequalities. We're just solving multi-step equations, which is what you did yesterday, but today you'll have a few special cases. So on the bottom of page 250, we're going to do number 1A first. All right, so we'll do this one, write this one down. Do I have that? And hopefully this thing works today. All right, what is the first thing we do in 1A? Distribute. We distribute the 4 to the x, and don't forget to multiply it by the 2, because I've been seeing a lot where people today will multiply it by the first number, not by the second. Rewrite everything. So rewrite the 3 even equals, this is 4x plus 8. Now you only have a variable on the right-hand side, so you're going to move the 8 over to be with the 3. And how do we move a positive 8? We subtract 8 from both sides. It will cancel. Negative 5 equals 4x. And then what do we do next?
You divide 4x by 4.
You divide 4 on both sides. So x equals negative 5/4. And you can just leave it like, if you want to change it, negative 1 1/4, or even negative 1.25. Any one of those is correct. Because now really, for the most part, you can leave things as improper. Because when we go to do slope and linear functions, we leave it improper anyway. Now for the check, 3 equals 4 times, I'm going to put negative 1.25 in here. Just because when I go to solve this, this looks like money to me, which makes it easier. You could use a fraction. 3 equals 4 times 75 hundredths, which is the same as 3/4, and 3/4 of 4 is still just 3. So our check works. It always makes me wonder when I get fractions and decimals as answers also, but they're completely fine to have that. Any questions on 1A?
Can we just check on our calculator?
No, you have to show your check. You can, once you write it down, you can. You can just type that into your calculator. That's fine. Just make sure you write it down. No. Now we are on section 2. This is top half of page 251. So we're going to do 2A and 2B. So 12m plus 12 equals 6 times the quantity of 3m plus 3. Everyone see where we're at? These two. What are we going to do first?
Distribute.
Thank you. Distribute. Rewrite everything else. 12m plus 12 equals 18m plus 18. Now this is just what you did yesterday. Aside from that extra step of distributing, this is just a multi-step equation, which you learned. I'm sure yesterday you were told the same thing. If possible, move the lesser of the 2 variable terms first. So here's a 12m and an 18m. Those are variable terms, so which one should we move first? 12m. It helps just to keep things positive. There are technically 4 different ways you can start this problem, but the less you have to deal with negatives, typically the better. Less chances for simple mistakes. Bring down everything that is still there. So bring down the 12. 18m minus 12m is 6m. Bring down the plus 18. Now your variable is already on the right. All your variable terms have been moved to the right, so you need to move your constants to the left. So what is still left to move? 18, and it's positive now, so how do you get rid of it? Yes, we're subtracting 18 from both sides. Bring down the 6m equals, what's 12 minus 18? negative 6. And then one final step is to divide by 6 on both sides. So m equals negative 1. And again, today you only have 11 problems, so just take your time on these. So to do our check, go back to the original problem. So 12 times negative 1 plus 12 equals 6. 3 times negative 1 plus 3. All right, make sure, and your calculator has parentheses for you to use. You don't have to put the negative 1 in parentheses. But negative 12 plus 12, and you don't have to distribute this. If you just have numbers, you can solve the parentheses. And I show all my steps just because I'm a teacher. So you have 0 equals 0 as your check numbers. Did anybody not get that? Did that make sense?
What was 2 times 1?
Negative 1. You did everything right. You just put that instead of Okay. Questions on 2A? You try 2B on your own. You try 2B, which is right there. So what is the first line underneath the problem? What should be my next line after I distribute the 5 and distribute the 3? What's my next line? Go ahead, Amelia.
5n minus 15, and then 3n plus 21.
Correct. Again, there really are 4 ways you could start this. Start moving things. You could subtract 5n, you could add 15, you could subtract 3n, you could subtract 21. But just so we're all on the same page, we're going to subtract 3n from both sides of the equation. That cancels on that side. You're left with 2n minus 15 equals, bring down the 21. Now what am I going to do? Add what? Thank you. Add 15 to both sides. 2n equals 36. Then what do I do? Divide by what?
Divide 2 by 36.
Divide 36.
No, yes.
I knew what you meant. So n equals 18. Is that what you guys got? I saw it on a lot of your papers. Then you plug it back in. And yes, the n means that the n would be on both sides, so the 18 would go in for both of them. That's what I'm saying. You don't have to distribute now. You can just solve in the parentheses and multiply by the outside number. You have to distribute here because you can't combine like terms. There's nothing to combine there. So 5 times 15, is that the same as 3 times 25? What is 5 times 15? And what is 3 times 25?
25.
So did that work?
Mm-hmm.
Yes. All right. Now most of your answers work and they look like this today. But we're going to get into some of my favorite things. They're special cases. Some are called, let me get to it. There we go. Okay. Some equations have no solution. Nothing works. When this occurs, the solution is the null or empty set, or you can do the 0 with a line through it. Or you can just put no solution. Other equations, everything works. That's called an identity. It means whatever you end up with, you'll have the same thing on both sides. Like you'll have 10 equals 10, negative 12 equals negative 12. It's the same thing on both sides. So this is a special case. Now, all of these are not going to be, every single answer today is not going to be no solution or identity. Maybe a few, but not all of them. So this is an example of an identity. It means everything works. Do you see how you end up with the same thing when you subtract the variable term and you're left with 10 equals 10? That's an identity. Remember, think about looking in the mirror. It's the same thing, right? You could actually, if you recognize it in this step, you see how right here you get the same thing equals the same thing. Every single number would work. Think about it. Say it's 2. What's 3 times 2?
6.
What's 6 plus 10?
16.
Guess what you're going to do on the same side? What's 3 times 2? 6. What's 6 plus 10? 16. It's the same thing, so you just solved the same problem twice. So everything will work. If you recognize it at that stage of the equation, you can just stop there and say identity. The other thing is called, again, no solution, null set, etc., etc. Whoop. And actually, I needed a perfectly good spot. What happens is, you get down, you're solving the equation. If you don't recognize it here, you add the variable to both sides. Negative 14 equals 6. Can negative 14 ever equal 6? No. It's not that the variable disappeared, because the variable disappeared and you can make it disappear in the other one. But this is never true. You'll get the one thing that doesn't equal the other. So do you see in the first example, identity, how 10 equals 10? 10 equals 10. It's the same thing. That's identity. Well, that's not true. No solution. Let's try a couple of these. So we're going to do 5A and 5B. So we have one of each. All right, so here is 5A. What's the first thing we are going to do on the left-hand side of the equation? Distribute. So negative 6r minus 8 equals, and then we can combine like terms now. Do you see that you have like terms to combine on the right-hand side? You have a negative 5r and what? Negative r, which is the same as negative 1r if you need to put that down. So what is negative 5 minus 1? Negative 6, and you put the r, and then we just recopy minus 8. What do you notice? Do you see how it's the same thing on both sides right now? You can stop here if you want and say identity. Because everything will work. Every real number will work. So when you go to do your check, pick a number. You pick your own number. 1, 2, 3, 0. Doesn't matter to me. You'll get the same answer no matter what on both sides every time. Say you didn't recognize it. Maybe they were in the different order, but so you didn't see it, and you added 6r to both sides. You're like in the groove working, you didn't even pay attention. Well, look, you'll still get the same thing equals the same thing. So this is identity. Again, when you go to check, pick a number. Make it easy on yourselves. Like, don't pick like negative 87. Feel free. And then we'll see what happens with 5b. We have 14 plus 8w equals 4 times the quantity of 8 plus 2w. Did I write that down right? So there's nothing to do on the left-hand side except recopy. And on the right, we're going to distribute the 4. So we have 32 plus 8w. Again, sticking with the whole, get rid of your variable terms first. What are we going to subtract from both sides? 8w. So we subtract 8w from both sides, and you get 14 equals 32. Is that true? Is that ever true? No. You can throw a does not equal, and this is called no solution, null set. This with the line through it. Whatever. You can't check those because nothing's going to work. That doesn't mean 0. That means no solution. So you don't even have to check those. So in your work for today, number 11 is a word problem. It has an answer. It's multiple choice. 6 have solutions. 2 are no solution. 2 are identities. Okay, so 6 are just plain old multi-step equations. 2 have no solution. 2 are identities. So let's take a look at 1 through 11. The word problem, just keeping it real here. You don't need to write an equation for that. You can just reason through it and solve it using math. And I'm not going to be unreasonable and tell you can't do that.